In this series of videos, we're going to be looking at different kinds of counting problems and how to solve them. We begin with this example. We have 3 balls inside a bag. One is blue, one is red, and one is yellow. Let me add that we cannot distinguish them other by the color. And without looking, we select one ball, we write down the color, we replace the ball in the bag, and select a ball again. And the question is, in how many ways we can do this? So because we don't have that many choices here, we're just going to look at what are the different options. Let's say that we select the first ball and it ends up being a blue one. Then we put it back and then we have to select the second ball. And for this second selection, the options are going to be either a blue ball, a red one, or a yellow one. We assume that the first selection was a blue one, but it could have been that the first was a red one, and then we will have the same 3 options afterwards, or the first one could have been yellow, and again we can pick blue, red, or yellow. So basically in this case, with this tree diagram that usually we like to really put it as just one tree, let me move this here. So we are saying the first step, either we take blue or we take red or we take yellow, and then we run the second step. So the choices, we can see them here, and we could have written them as a list: blue, 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 red, blue, yellow, red, blue, red, 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 yellow, yellow, blue, yellow, red, yellow, yellow. So how many ways? Well, we can do this in 9 different ways. Notice that here it's very important what we mentioned here, that you select one ball, you write down the color, and then you replace it in the bag. This is what we say, but this is what we call a random selection that is done with replacement. So this is done with replacement. It can be interesting to consider the same problem, but modifying the replacement condition. So now we are going to repeat the experiment, but this time after we take a ball and we look at it, we do not put it back in the bag. I move this here so we can see it. So we repeat the experiment, but this time we don't replace the ball in the bag. So let's look at what are the options that we have over here. First time we pick blue, then the second time we can pick red or yellow. Not blue because there is no blue anymore. And in the second case we could pick red, but then we can pick either blue or yellow. We don't have the choice of picking red because it's not there anymore. And similarly with yellow, we can pick afterwards either red or blue, but not yellow. So in this case there are 6 ways. And we say that in this case the experiment is a random selection without replacement. Now, we were able to solve this problem just by considering all the options, all the possibilities we had. But this wouldn't be so convenient to do if, let's say, the balls were balls numbered with numbers between 1 and 99, and we want to repeat the same, and we want to pick and replace the balls for 7 times. Then definitely we wouldn't want to make a tree diagram or a table and list all the possibilities, even though the reasoning will be the same. In this case, it's just numbers that are so small that it's worth looking at all the possibilities. But let's see in the next video what do we do when really we don't want to list them all. I notice here that I'm missing one branch from the tree. It was just a careless mistake, and I'm adding it here with green just to make sure that you saw that there should have been a branch there.